most important things I can teach you in statics is the steps to solve an equilibrium problem. These are the same kinds of steps that you will use over and over again in engineering. And the more you get used to thinking about them mindfully as you're going through and saying, here I am, I'm following these same steps, the easier it will be when you approach a problem that you really don't know how to solve. Sooner or later you will get to one and you look at it and you think, I have no idea how to solve this. And this is where these kinds of steps really come in. I want to sort of emphasize reading the problem. It's a silly thing to say, but all of us have had the experience in calculus or physics or engineering where you look at the picture and you think you know what you're supposed to be doing, and lo and behold, at the end of the day, you've done the wrong problem. So I do encourage you to go ahead and read it and make sure that you're actually looking at the words. There's often information in there too that if you might have missed if you just went by the picture. The second thing you want to do every problem in statics is to draw a free body diagram. If you don't know what that is yet, don't panic, but you're going to need to be drawing pictures. Often a lot of pictures. So you're going to draw a free body diagram of this, you're going to draw a picture of that, you're going to sketch this other thing. Every problem starts with some sort of hand-drawn picture. State your givens. Go ahead and write them out. I know that's something that your high school teachers have taught you to do. The more you do it, I mean, there is a reason we keep saying this. State your givens. What do you know? What do you want to know? Part of this is translating these word problems into whatever kinds of variables you're going to use in the problem. Often, if you're actually translating this all into the variables, you might notice you're missing one. And that's a hint for one of the things you're going to need to do next in your problem. Once you have your givens written down, write your equations of equilibrium or other equations that you're going to solve in the problem. Get in the habit, please, of writing down the formulas in all of their original, this is where it came from in the book, before you substitute in numbers. Yes, that makes your problems a little bit longer, but when you're going back to study for the final, or heavens, looking back at what you did 3 years ago, it's really nice to have the formulas written down in your work. Solve your equations. That's where you're actually going to do the work. Many of you will think of that as the whole point of the problem. It's not. It's only one step. After you've solved them, go back and answer the question. What were you actually asked? This is where reading the problem comes into play. And what I mean by answer the question is, in English words, so you're going backwards from this step here. In English words, what did the problem ask you, and have you answered it in those kinds of terms? Are you using the right number of significant digits? Are you using units? Have you answered the problem in some fashion that wasn't defined in the problem? So perhaps you put on an XYZ axis and you've told me now that your answer was 3i plus 4j. Well, if I don't know where the x and y axes are, that's not helpful. So answering the question is actually like giving a report to your customer. What did I ask you? What are you telling me the answer is? And perhaps the most important step here, the one that students skip most often, is checking your work. Does your answer make any kind of sense at all? I mean, we're working in engineering in a field that's very physical and concrete. If I've asked you what the position vector is from here to Durham, and you tell me an answer that's in units that would get me all the way to Mars, that's the kind of thing where you can look at it and say, does this make sense? All of those third grade approximation lessons come into play right here. And you have to do this. It's one of these most important points. Engineers, here's the old joke. If a pilot crashes a plane, he might kill 20 people. Or if a doctor makes a mistake, he might only kill one. But if an engineer makes a mistake, he can kill 100 or 200 at a time. It's very important that you get used to checking your work, even at the beginning of an engineering career, so that you aren't that person. Thanks.